Hello, young math Padawans. It's Mrs. Angel with your lesson for today on inverse trigonometry. Well, let's look at what we know. Currently, we do know how to use trig, our sine, cosine, tangent over here, to find the missing sides of triangles. But today's key question is, can we use those same ratios to find missing angles? So let's get into today's warm-up. In today's warm-up, you're going to circle the focus angle, label its sides, choose the correct trig function, write an equation, and solve that equation using a calculator. So here we have our triangle, our focus angle, and two sides of this triangle. So take a moment and complete this warm-up now. So it looks like here we are given the opposite side and the hypotenuse, which means we're going to be using our sine function. So I'm going to go ahead here and circle sine. So our angle is 30 degrees, so sine of 30 equals our opposite 2 over our hypotenuse x. Now we have to find the sine of 30. Well, there's two things that we can do. We can either use our table or we can use a scientific calculator. So using the Desmos scientific calculator, I see here that I have sine, cosine, and tangent. I can also, if I wanted to, click on the functions button and the same three are there, sine, cosine, and tangent. So we're trying to find the sine of a 30-degree angle. So I go to sine 30, and it looks like my answer is 0.5. So going back to my work, I now know that sine of 30 is 0.5. And now I can continue to solve this equation. I notice x is in the denominator, so I'm going to multiply both sides by x. That will lead me to 0.5x equals 2, and divide both sides by 0.5. And 2 divided by 0.5 is 4. And if we round that to one decimal place, that would be 4.0. Okay, so here we know now that the hypotenuse is 4. And then if we wanted to find the rest of the information of this triangle, we could. In fact, you may have noticed this is a special type of triangle. This is a 30, 60, 90 triangle. So we know that the adjacent, or the long leg, is just a short leg times root 3. So now we found everything that we need to know about this triangle. Now that seems pretty straightforward, but here's our what if question of the day. What if we were given the opposite and hypotenuse, but asked to solve for the angle? So notice here, this is almost the exact same triangle in our warm-up. In fact, it is the exact same triangle. But this time, we're not given an actual angle measure. We're given theta, which is a variable used to represent that angle. We're also given the opposite side and the hypotenuse. So if sine of theta solves for the missing side, then we need to do the opposite of sine to solve for the missing angle. But what is the opposite of sine? To understand that, we need to come up with a different word for opposite. In math, a lot of times we will use inverse to mean the opposite. It will undo something. So inverse of addition is subtraction. Inverse of taking the square root is squaring. It will undo that operation. Do you know what the inverse of sine is? It's called inverse sine. I know, it seems like they were so lazy they couldn't come up with another name for it. Let me show you how this works. So here's our sine function. We have sine of our angle theta is equal to the opposite side over the hypotenuse. But what if we're trying to solve for the angle? We need to isolate theta, which means we need to somehow undo taking the sine. To do that, we would take the inverse sine of this function. So to show inverse sine, you're just going to write out sine raised to the -1, and that is called the inverse sine. And we're going to take the inverse sine of both sides. So we took the inverse sine of sine theta, and we took the inverse sine of our ratio opposite over hypotenuse. Now, what does that leave us with? Well, taking the inverse sine of sine will undo that function. So this is now officially undone or negated, and we are just left with theta. Kind of like how addition will undo subtraction, division will undo or negate multiplication. It's the same idea. And on the other side, we just have the inverse sine of opposite over hypotenuse. And this is called an inverse trig function, or inverse sine. Okay, so let's go ahead and use it now. So if sine of theta is equal to 2 over 4, but we want to solve for theta, we want to find our angle measure, we have to take the inverse sine of both sides. Notice again, this is a function, this is negating taking the sine of, this is not multiplication. So what happens when you take the inverse sine of sine? Well, those are negated or undone, and you're just left with theta and inverse sine of 2 over 4. Okay, but that still doesn't give me my angle measure theta, which, by the way, from our warm-up, we know it should equal 30 degrees because this is the same triangle. Well, if we go back to our scientific calculator, there's actually something interesting. If we go to the functions tab again, you'll see our inverse function. There's inverse sine. So we have inverse sine of 2 divided by 4, and what does it give us? 30. So according to our calculations, the value of theta is 30 degrees, which we already knew because we were working with the same triangle. So if trig functions, sine, cosine, tangent, allow us to solve for a side length, the inverse trig functions allow us to solve for an angle measure. So let's take a look at cosine and tangent. All right, can you guess what the inverse of cosine is? If you said inverse cosine, you're correct. So to negate cosine and isolate theta, we're going to take the inverse cosine of both sides. So the inverse cosine of cosine theta and the inverse cosine of our adjacent over hypotenuse. Now what happens when I take the inverse cosine of cosine? These are negated and that work is undone, and I'm just left with my angle theta equals inverse cosine of adjacent over hypotenuse. And there is my inverse cosine function. What about tangent? Again, I notice that I have tangent theta equals opposite over adjacent, but I want to get theta by itself. So can you guess what the inverse of tangent is? How about inverse tangent? You guessed it. So to undo taking the tangent of theta, we are going to do the inverse tangent of both sides. So inverse tangent of tangent theta and inverse tangent of opposite over adjacent. So what happens when I take the inverse tangent of tangent? That is negated or undone, and I am left simply with my angle theta equal to inverse tangent of opposite over adjacent. And that is my inverse tangent function. So now that we have all of these inverse trig functions, let's put them into our practice. At the top of our practice, I wrote down our 3 inverse trig functions. I suggest you do the same because we don't actually have to take the inverse of both sides. We can just use these functions to set up and solve our equations. So looking at example A, here is our indicated angle theta, and it is unknown. We do not know the value of theta. However, what are we given? We are given the opposite side to theta and also the adjacent side to theta. Opposite and adjacent. Which function are we going to use here? We're going to use the inverse tangent function because we are solving for an angle given the opposite and adjacent. So our unknown angle is theta equals the inverse tangent of our opposite side, 17, divided by our adjacent side, 48. And we can take that right here and plug it straight into a scientific calculator. So in our graphing calculator, we're going to find the functions button, and there is our inverse tangent. So we're taking inverse tangent of 17 divided by 48, inverse tangent 17 divided by 48, and our answer is 19.5024, blah, blah, blah. So just round it out to one decimal place, that's 19.5. So theta is approximately 19.5 degrees. All right, let's take a look at problem B. So our focus angle here, theta, and it looks like this time we are given the length of the hypotenuse, 55, and the adjacent side, 37. So which function are we going to use to solve for theta here? Since we're given opposite and adjacent, we're going to use our inverse cosine function. So our angle theta is equal to the inverse cosine of our adjacent side, 37, divided by our hypotenuse, 55. Let's grab our calculator, go to the functions tab, and find inverse cosine, and then type in 37 divided by 55, and our angle measure is 47.7 degrees. So theta is approximately 47.7 degrees. All right, problem C. Here is our angle, and it looks like we're given the opposite side and hypotenuse. So which trig function are we going to use here? Opposite and hypotenuse, we are using our inverse sine function, opposite over hypotenuse. So our angle theta is equal to the inverse sine of our opposite side, 22, over our hypotenuse, 25. All right, let's grab our calculator. So function inverse sine of 22 divided by 25, and it's about 61.64, so 61.6 degrees. So theta is approximately 61.6 degrees. Now it's your turn. Go ahead and complete problems D, E, and F on your own now. Let's see how you did. For problem D, you are given the opposite and adjacent sides, so we're using our inverse tangent. So theta equals inverse tangent of 16 over 20. Let's grab our calculators. So inverse tangent of 16 divided by 20 gives us an angle measure of 38.659 or 38.7 degrees rounded. So theta is approximately 38.7 degrees. For problem E, you were given the opposite and hypotenuse. So the function was our inverse sine. Theta equals inverse sine of opposite 34 over hypotenuse 35. So grabbing our calculator, we have function inverse sine of 34 divided by 35, and it appears our angle is 76.27 or 76.3 degrees. So theta is approximately 76.3 degrees. For problem F, you were given the adjacent side and the hypotenuse, so our function was inverse cosine. Angle theta equals inverse cosine of adjacent 28 over hypotenuse 35. So for our function, we're using inverse cosine of 28 divided by 35, and our angle measure is 36.869, so 36.9 rounded. So theta is approximately 36.9 degrees. So to quickly recap, our sine, cosine, and tangent functions are used to help us solve for a side length. If you're given an angle, you can solve for a side length. However, if we're given the side lengths and need to solve for the angle, now we have our inverse sine, inverse cosine, and inverse tangent functions. That's it for today's lesson. I will see you next time.